Today we're going to be talking about function overloading, which is going to allow us to have more than one copy of the same function. Now you might be watching at home saying, whoa, we already have so many functions to deal with. Who do you think you are coming in here and making copies of them and messing everything up? Are you insane? I might be insane, but you're inconsiderate because you're just thinking of all the integers out there. What about the floating point numbers? Those are the decimal numbers. Yeah, you forgot about them. You're treating them like second-class citizens or second-class variables. What if you were to pass one of those floating point numbers through your function, the one function you make, which was looking for an integer? Well, you're just going to go ahead and cut off everything beyond the decimal point. It's not even going to round it up for you. It doesn't care. You're just going to say, we don't like your type around here. We believe in variable equality. So we're not going to do that. We're going to make more than one copy of the same function, which is function overloading. And in one of them, we are going to have a parameter, which is going to be an integer. And the other one, we're going to have a parameter, which is going to be a float, for floating point number. And as long as your parameters are different, you're allowed to have more than one copy of the same function. This means that you can either have no parameter in one and a parameter in the other. It means you can have one integer in one and two integers in the other. Or you can have an integer in one and a floating point number in the other. As long as you don't have two of the same. So you have, like, say, two integer, wouldn't work. I'll show you guys what that means in a moment. So let's go ahead and get started here. It's easier for you guys to visualize if I start typing. So we're going to go ahead and inside our main, let's go ahead and make two variables. We'll have integer w, which is going to be 5. And we'll have float for floating point number whenever you want to put a decimal. Float v, and that will be 3.95. And the reason I'm putting 3.95 is just so you can see that if you were to pass that through an integer, you're not even going to round up to 4. You're just going to get 3. It's not even going to take anything in consideration. It's a jerk. So we have these two things right here, and we're going to go ahead and make our functions. So make them down here. We're going to call these void because we don't want them to return anything to us. And we're going to call it the overload function. So just call it overload like that. Make another one right here. And then put it right there. Now you're going to see we're going to get an error here because you can't have two of the same function. There's no point unless you're putting different parameters through it. So the first one here, we're going to pass integer x through here. The second one, we're going to go ahead and pass, see right there you see the error already disappeared just because they're different, even though I haven't put anything in the second one. But I'm still going to put something different anyway. I'm going to put float x, and now you see we have no errors, which means the parameters are different, so we're allowed to have two of the same function. I'm going to have this one print out x. It's going to believe that x is going to be an integer. I'm going to have this one over here print out x as well, and it's probably going to think that x is a floating number. So we have those two things right there. Now we have to prototype them as we've always done. So we're going up here, I'm going to copy everything except for the body in here. So we'll put void overload integer x and void overload floating point x or float x up there. So we have all those right there. And now our functions are ready to go. So it's going to pass through our numbers and it's going to see if it's an integer, it will use this one. If it's a floating point number, it will use this one. It's pretty smart actually. So we can go down here and we can go ahead and we can write our function. And we already wrote that we have cout and all this. We just need to call upon our function by writing it except for the data type. You don't need to write the data type again. You do that when you're prototyping. So just going to write overload, and now we see integer x. So say I would just put w in there. Put w, it's going to see, oh, what is w? W is an integer, so it's going to go and it's going to say, ooh, which one has an integer? We'll take this one over here and we'll go out through that. So I'm going to go ahead and I'm going to print this out. You'll see the build has succeeded, and we're going to get 5 out there. Perfect. If I were to go and put v here, which I will show you guys what would happen if we go and delete the one that's accommodating the float in a moment, we'll see we'll get the decimal printed out here, which is awesome. This might not mean anything to you until I go ahead and do this. So what if I went to do this, and what if I went to do this? Uh-oh, we don't have the one that accommodated the float anymore. Let's go ahead and build and run this. We're going to still get build succeeded, but look, we're only going to get 3 out there. You didn't even get any rounding. So you see what problem you get when you go ahead and put a float through an integer function or function with an integer parameter. It doesn't work. Overloading allows us to avoid this. We make a copy of the one we're making. So I can go ahead and do it one more time here for you guys. Make a copy. So overload float x. It has the same name and everything inside is exactly the same. And you're going to go prototype it up here, exact same way. Right there. And now this one will accommodate the float. So whatever one you pass through, it's going to accommodate. And you can go ahead and make it like this. You can do them both at the same time, build and run, and you'll see that it's automatically going to pick which one it needs to go to. This one's going to pick to go through the integer one to save a bit of memory, and this one is going to pick to go through the float because it needs to have the precision that it requires. It's obviously much more precise to have a decimal place right? Saying 3.95 is much more precise than 3, because if we're just saying 3, we don't know if it's on the high end of being a 3 or a low end of being a 3. The decimal place gives that. That's why we need more memory for a float, because it needs to be more precise. Hope you guys enjoyed the video. If you have any questions, leave them in the comments below. Function overloading might be a little bit confusing. I remember when I first learned about it, it was a little bit confusing. So if you have any questions, please leave them below and I'll answer you guys as soon as possible. Thank you very much for watching, and I'll have more videos coming up later.